In this video, we'll take a look at the information that should be collected when troubleshooting 3PCC IP phone issues. The first item we're going to look at is the actual problem statement. Number one, please provide a detailed description of the problem statement. This should include steps to reproduce the issue, if possible, a video recording, and any other related information that may be helpful with the troubleshooting efforts. So we really want to identify what specific issue are we seeing with the actual phone, and any steps as far as that the users have noticed that can generate the problem. This will be very critical information when you're working with a Cisco partner and or Cisco technical support, that the problem statement is very clear. Next item, is the issue constant or intermittent? What is the failure rate? Is there a pattern tied to the issue? So basically here we want to understand, did the issue only occur once, and since it has occurred only once, it's never reappeared again? Or is it an issue that occurs maybe once or twice a week? And is the issue actually tied to any other specific activity? For example, if the issue only occurs Monday morning, 7 o'clock in the morning, or specific times of the day/week. Third item, is the issue tied to a specific phone/phone model, or is it global in nature? In this item, we want to understand, is the issue tied basically to a single model of phone and or a specific phone? So let's say we have 10 7841 3PCC phones and only one phone is exhibiting whatever the issue is. We want to understand, is there something peculiar about the phone, or perhaps where the phone is located as far as from a networking standpoint that may be generating whatever issue that the user is seeing with the phone. Next item is going to be, how many phones are having the issue? Is the issue isolated just to one or two phones, or are all the phones exhibiting the exact same issue? Item number 5, is the issue tied to a specific location, such as a floor, a building, or a site? And this is actually a very good approach to troubleshooting an issue. If we know the issue is not seen at a different floor or a different building or a different site, then one of the things you could do is you could take one of the phones that's having the issue and just swap it with another phone at another location, and then see if the issue follows the phone or if it stays with the location. If the issue stays with the location, then most likely it's not an issue with the phone. There's something either at the switch where the phone plugs in at the original location that's causing the issue, or something within a network segment. Something might be generating a lot of traffic, or there might be something else going on that's causing the phone to exhibit the issue. Okay, next section will be network typology. Please provide a network typology map, even if it's a basic hand-drawn typology map. Definitely, when you're troubleshooting and you're getting a Cisco partner involved and or Cisco technical support, definitely be prepared to have some type of typology map. It doesn't have to be a super great detailed typology map, but you definitely want to have something drawn out. You can very quickly generate a topology map. Assuming you have managed switches, you can log into each respective switch and you can do a show CDP neighbors or show LLDP neighbors, and you can very quickly, by doing this on each of the switches in the pathway of the phones, as far as the SIP and a RTP call pathway, you can generate a topology map. So that's something that even if you don't have issues with the telephony and or networking, you should always have some type of topology map ready if an issue was to develop. Next item, please provide the call controller SIP server type and version. Again, very critical. Is it Webex Calling that you're using a 3PCC phone with? Is it open source SIP server, free PBX, asterisk, etc., etc.? Number 3, please provide the phone model and firmware version. Yeah, definitely make sure that you indicate the specific phone model and version. You can look at the back label on the phone, take a picture of it. Also, there's information within the phone 2E telephony user interface, basically LCD on the phone. Number 4, please provide the switch make, model, firmware version, running configuration, and also is the phone using PoE and what type of cabling is the phone using between the switch and the phone itself. Depending on what the problem is, this is something definitely information you want to gather up. Is there any pre-existing issues with that switch and that specific phone? Is the firmware very, very old on a switch? The running configuration, does it have a special type of running configuration that may not work well with the phone? So these are all items we want to take a look at. Also cabling, if you have very old cabling and it has multiple insertion points between actual phone and the switch itself, that can also at times introduce different issues. Last item on this page, number 5, provide any other equipment / software information that may be related to the phone issue. Yeah, so if there's anything special in your environment that you have running, for example, let's say you have you're running a lot of multicast, you have digital signal processors, maybe you have a very large meeting room, whatever the situation might be, make sure you include that information because it will definitely help with the troubleshooting efforts. Okay, so this next one's going to be site setup. Is this a deployment that was working and recently developed issues, or is it a new deployment? Very critical question. So if this was a deployment that was working A-OK and then just recently developed issues, then the very first question to really ask is what changed? If it was working fine for 2 years and then suddenly the other week issues started appearing, obviously something must have changed for the issues to develop. So that's something, most companies have change control to minimize changes, so you're not changing multiple things, you're only changing one thing. So if there is an issue that is noticed after the change, you want to roll back. So if it's a firmware upgrade, let's say in the switches or whatever change, you want to be able to roll it back and then see if the issue or the symptom disappears. Number 2, are any accessories used with the 3PCC phones, example, keyboard expansion module, headset, etc.? If yes, what is the make / model of the accessories including any cable information? So if you're having issues and you're using accessories with the phone, one of the things you may want to try is temporarily removing that accessory from the phone, or looking at a phone that does not have that accessory but it's the same make, model, firmware. Does the other phone have issues? Just to eliminate any variables on what can be introducing the symptom or issue that you're seeing. Number 3, did any changes occur before the issue started, such as a firmware upgrade, call controller upgrade, session border controller changes, switch, router, firewall, service provider, or phone firmware upgrades? We mentioned this a moment ago. If things were running fine, example, for 2 years, and then suddenly last week you start seeing issues with certain phones, then this is number 3. This is the item you really want to ask. Did anything change in your environment? Did anybody update firmware? Did anything change from a service provider, from a security router, firewall standpoint, etc., etc.? Number 4, is the issue seen with the latest 3PCC phone firmware? If you're running very old firmware on the phone, this might be one of the first things to look at. Please be aware, if you are using the phones with Webex Calling, the firmware does get automatically updated, so that's something you really don't need to worry about. However, if you're not, and you're maybe running on-premise free PBX or some other third-party SIP server, then that is something to consider. Number 5, if it is a network issue, is there any port scanner or other type of additional traffic, example multicast, sending packets to the phone? Yeah, so this is really where you probably want to do a Wireshark capture on a switch port where the phone's at, and initially maybe just do 10 seconds and just see if there's any types of elevated traffic, ARPs, broadcasts. Generally for both ARPs and broadcasts, you normally would not want to see more than about 12 to 15 hits or packets per second, because for most networks, if you're getting hits beyond that and it's ARPs and broadcasts, that would be kind of suspicious. Why, what's generating so many ARPs and broadcasts? And then the other one would be multicast. If you're running multicast, especially if it's pro audio and video, you want to make sure that IGMP snooping is properly configured. Just the basic audio stream can generate thousands of packets per second of multicast traffic, and that can have a huge impact basically on any of the devices, but especially in devices with smaller CPUs. So IP cameras, printers, Wi-Fi access point, phones, IoT devices, Internet of Things devices. For example, touch panels you put in meeting rooms that show you the scheduling, touch controllers for meeting rooms, for automating audio blinds, etc., etc. So, some Wireshark captures, highly recommended. Just see if there's anything holistically from an evidence standpoint that might be contributing to the issue or might be the root cause of the issue. Okay, reproducing the issue. Can the issue be reproduced in a lab environment or at a different site/network location? So this is actually a very good question. So this is something definitely we want to know, is the issue intermittent/very random, or is this something that we can fairly consistently reproduce? If it's something that you can fairly consistently reproduce, definitely document that information as far as what are the actual steps that you're taking to reproduce the issue. So when you go ahead and contact the Cisco VAR and or Cisco technical support, you have all that information listed, exactly what are the steps and effort that they can reproduce the issue, and then figure out exactly what would be the solution. Is it going to be a firmware upgrade? Is it going to be a configuration change, etc., etc.? Number 2, does the issue have a known trigger point that will generate the issue? Another very good question. Is there anything in the environment pattern-wise that anybody has noticed as far as the users that are using the phone that is a trigger point when X application is running, the phones have issues, or the phones have issues Monday morning at 7 o'clock, but then by afternoon the issues go away and there's no issues the rest of the week? Example, is there a backup that starts on Friday evening and the backups have gotten so big and they're via site-to-site VPN, thus, i.e. they're using the internet connection, and now they're rolling into Monday morning where they're consuming a majority of the available bandwidth, thus impacting the telephony, the phones, if you will, because they're cloud-based nowadays. And so, there's a lot of different variables they can be introducing or being the trigger point. Go ahead and gather information from the user, see if anybody notices any specific trigger points that may be contributing or causing the actual issue. Okay, next section is going to be logs and packet captures. Please provide packet captures from a mirrored switch port, span switch port analyzer, and corresponding PRT and or syslog files. In the description below, I will have a link to how to generate a PRT file from a 3PCC phone that is registered to Webex Calling. So that's something definitely you want to take a look at if you've not had to generate a PRT file before from a 3PCC phone. Please indicate when using Please indicate when the issue occurred related to the PRT/syslog files. Also indicate during the packet capture at what point of time, and it shows it here in seconds, into the packet capture the issue occurred. So basically we want to have some type of documentation timestamp, if you will. When did the actual issue occur? So if we're going to be analyzing the PRT/syslog files, then basically what you want to do is you want to document as far as day, time, also time zone when the issue occurred, in effort that information can be then correlated to the specific time segment in the PRT/syslog files. So, and that'll help quite a bit, because otherwise a lot of time can be burned up looking at information that's just noise as far as the PRT/syslog files. So if specific time segments of when the issue occurred, time, date, and also time zone can be indicated, they'll help quite a bit when technical support looks at the actual PRT/syslog files. And then if you're doing Wireshark captures, packet captures, if you will, they won't necessarily have timestamps, but they will have stamps as far as seconds and minutes as the packet capture is running. So you'd want to indicate that after 120 seconds the issue occurred. Thus, the person, engineer analyzing the packet capture can focus on that section to see what happened right before, what happened during the issue, what happened after the issue. Okay, and that kind of touches upon number 2. Please document the days, times the issue occurs, including the time zone of the phone. So we talked about that, very critical. Also, please gather any SIP server logs, if available, with timestamps of issue. So obviously there's two parts of the puzzle. There's the part that the user that's using a phone experiences, which would be the phone itself, the 3PCC phone. Obviously we want to gather information from the phone itself in this manner of PRT and syslog files. But then on the other side of the fence we have the actual SIP server. So if it's a situation where information can be gathered from the SIP-log server, that information should also be gathered, so both ends of the spectrum can be analyzed and compared to each other to understand exactly what's happening. Is there something in the middle that is manipulating the packets that's causing an issue? Session border controller, some type of firewall that has application layer gateway functionality with SIP protocol that's inspecting and or manipulating the packets, and thus causing whatever type of anomaly might be seen. Okay, and then in this section we'll just briefly take a look at a basic typology map. This is very generic in nature, but just to kind of sum up all the things that we have covered so far. So for example, if a user is reporting an issue with their 3PCC phone, we want to understand exactly what type of issue are they seeing. So you definitely want to gather information. Is the issue that the phone is having problems getting the dhcp IP address? Is the issue that the phone is getting or is having issues getting proper PoE, meaning it's going offline at times or doesn't want to even power on? Is the issue maybe related to the phone is getting IP address, but it's getting the wrong IP address because it's latching onto the wrong VLAN? And so these are some of the variables we want to take a look at. So if it's an issue where it's getting the wrong IP address, we want to figure out, is the switch propagating the VLAN information via CDP and or LDP to the phone itself? Is the switch configured as a trunk port where the phone plugs into the switch? And this will vary between different switches. If they can detect if it's a phone, it'll try to auto-configure the port, or if it's a manual configuration. So this is something definitely whoever is managing the switch needs to be involved and kind of see for that specific make and model switch what might be a requirement. The other thing also to be aware is, what is the firmware vintage in a switch? Sometimes what I see folks make a mistake is they never upgrade the firmware on their switch. They bought a switch maybe 3, 4, 5 years ago and they just installed it and the firmware was never updated. Most switches in the lifespan, they'll go through actually quite a lot of updates, firmware updates. They'll have some minor firmware updates, and they'll have some major firmware updates where there's new features, new technologies added. So this is definitely something to consider. If it's an unmanaged switch, then that switch does not have any concepts of VLANs or CDP or LDP. It obviously would have PoE if the phone is using a switch as far as PoE, and then dhcp would be not provided by the switch, but it will be provided either by, in this case, a distribution layer switch, or it could be also in a data center block, depending on the network architecture, as far as, more of a distributed DHCP type of architecture or more of a centralized architecture. The other thing also to be aware as far as PoE, and this is not specific to phones, but it's more of a global statement, is if you're running into any type of odd PoE issues and the PoE devices are going offline, or they're going to sleep and they're now waking up, etc., you may want to check and see if the switch has something called EEE, Energy Efficient Ethernet, also known, it may also be known as Green Ethernet or Energy Saving Ethernet. There's different names it might go by. And if it does have EEE and it's enabled, you may want to disable it for the respective port where the phone is plugged in. And this again can apply to IP cameras, WAPs, a lot of different devices or PoE. If you're seeing issues, that's one of the first things you may want to take a look if it's related to power, the device, falling offline or going to sleep, etc. Going back to DHCP, DHCP has been used actually for a very long time, since the 90s, late 90s is when the IT marketplace really started using DHCP, when IP really became dominant with internet, etc. So it's something that's been around for quite a while. You still may run into some anomalies here and there depending on what device is acting as a DHCP server and where it's located at. So if you're doing some type of high-end multiple DHCP servers in a redundant cluster configuration back located in the data center, and then a DHCP request packet needs to go all the way up through the access layer switch, distribution layer switch, core switch, all the way back to the data center block, again down to the distribution layer switch, data center switch, and then the data center block, plus you have two DHCP servers here, and then they need to respond all the way back across the network typology, all the way back to where the phone is. If you're having DHCP issues, first we want to make sure, is the phone generating the DHCP request packet, discovery packet, and easy, just do a Wireshark capture at the point where the phone plugs into the access layer switch. And if that seems a-okay, then we want to see a response back from the actual data center block. The DHCP servers are located there. If we're not seeing a response back, then we want to do a Wireshark capture basically at the location where the DHCP servers plug into the data center switch. One, are they receiving the DHCP discovery packets? And if they are they responding back? If they're not responding back, then the next thing is to actually look at the DHCP servers themselves and take a look at their logs and see if they're running out of IP addresses, if there's a misconfig, are they running old firmware, and if firmware has some type of bug, where in a DHCP cluster, after a point of time, resources get exhausted or something occurs that they don't function quite correctly. So again, it's kind of a multi-tier analysis. We want to start off basic with the device that the user is reporting the problem with, and then we want to figure out what specific protocol we're looking at here and what is servicing the protocol. If it's DHCP, then it's going to be either the access layer switch, the distribution layer switch, or it may be servers located in the data center block. Example like Windows Server 2019, or they may be some other appliance that the customer is using for their DHCP servers. And then the other item would be if telephony is having issues as far as registration, firmware updates, etc., So if that's one of the issues you're facing, you probably want to take a look at the firewall. And when I say take a look at the firewall, look at the actual logs on the firewall and see if it's indicating that if it's blocking any of the packets from a 3PCC phone. So again, the symptom would be, you're trying to register a 3PCC phone to Webex Calling and nothing happens really. You generate a registration code, or you go ahead and register the phone via its MAC address to Webex Calling, and you're not really getting any errors, but nothing's really happening from a registration standpoint. So there, we want to take a look at the firewall logs. We also want to look at the PRT file from the phone itself, because that's also going to tell us, what's occurring. And then the other thing also is we can do another Wireshark again. We can do a Wireshark at the access layer switch, port mirroring, plug in a notebook to this access layer switch right here, running Wireshark, and then the source port will be the port where the phone plugs into the access layer switch, the destination port where the notebook with Wireshark is plugged in, and then just start up Wireshark and go ahead and reboot the phone, or actually go ahead and generate new packets so it can try to register to Webex Calling. Give it a few minutes, 4, 5, 6 minutes, if you will, and then see, you'll see packets from phone traversing out, but then a question, are any packets coming back from internet? If no packets are coming back from internet, but yet the phone is sending a bunch of packets out, then again, we want to look at the firewall. And then the other thing is, you could also take the phone to a different site. If you have multiple sites, you can take it to a different site and see if you get the same symptom. If the firewall policy or security rules are the same at each of the sites, then you may run into the same issue. If you're permitted, take the phone home and plug it into your home network. You obviously want to make sure you have either a PoE switch or mid-span injector, a PoE injector. If it works in your home network, but it doesn't work at the office network, then again, most likely there's something with a firewall going on. And then the other item is also, since a lot of the telephony nowadays is done with cloud-based telephony, example, Webex Calling, Internet by default does not have any concept of QoS. It's best effort. So if your site is saturated as far as traffic, downloading traffic or uploading traffic, depending what your business is involved in, etc., it could be certain times of the day that the quality of the calls is very, very poor. So this is something definitely you'd want to analyze. There is a tool I'll actually talk about in a moment that Webex does offer. It's very easy to use. You can do some analysis to understand if there's any type of constraints for your internet access as far as bandwidth, latency, and packet loss. The other thing also to be aware is on internet, it's a network basically that's tied together by many different providers. They have basically points on the internet where they actually do traffic handoffs between each other. So it is possible, depending where you're located versus where the data center is located at, where the phones are registering, and also the VoIP routers or the SIP media servers are at. That's where the actual audio portion of the phone transactions handled, the RTP traffic, if you will. That between those 2 points, again, there may be a lot of congestion, bandwidth limitations, there may be a lot of jitter, and also there may be a lot of packet loss. And the tool I'll talk in about a minute here will kind of expose some of that information and see exactly what is occurring. Okay, now we're going to take a look at the Webex CScan tool. The location is cscan.webex.com. And for the test test, we'll just select United States. We'll leave it English. We'll go ahead and pick the server. We're going to do advanced diagnostic, and let's go ahead and start the test. Okay, if you notice, it's giving us some statistics on latency, 83 milliseconds, which is fairly decent. Okay, my download speed is in a mid-60 megabits per second. This is a cable modem connection that we're using from a home network environment. So it looks like we're inching towards the high 60s now. Okay, and then the upload speeds. I do have some other things going on in the background. So my upload speed is about half of what I normally would have running. But in any case, this gives you kind of an example what you might see when you run this in your environment. Okay, so based upon what the CScan tool has analyzed, it's telling us the estimated concurrent possible calls will be 7. It shows the public IP address. It shows the browser I'm using. It's showing the actual latency in milliseconds. And if we click on this small icon right here, it gives us actually the definition. Oh, let me try that again. Round trip time. So less than 200 milliseconds is good. If you've looked at any of the traditional documentation or taken up the training certifications, et cetera, regarding VoIP, unified collaboration, so forth and so on, historically 150 milliseconds or less was considered good. Nowadays the number has changed a bit. It's up to 200 milliseconds or less. 200 to 300 milliseconds is fair, and then more than 300 milliseconds it's poor. And basically the side effect would be when talking to another person, it would almost start being like talking in a CB radio, where you would have to tell the other person over to let them know that they've finished talking and for the other side to start talking. So that's really where the round trip latency really kicks in, is you don't want it to be too high, otherwise both people may attempt to start talking concurrently, and obviously it's going to be a very difficult conversation if the latency is really high. Okay, and then this shows us the actual ports. Port 80, it's open. Port 443, so these are used for management. And then the call signaling to Webex Calling is port 8934. Okay, so let me see. So let's take a look at this right here. Okay, it says concurrent calls so it's a conservative number estimate they're giving us. They assume 50% overhead of other traffic on the network, and assume all audio calls require 2 legs at approximately 100 kilobits each. Okay. And then let's go and take a look at the port requirements. Okay, so port reference information for Cisco Webex Calling. So it looks like in this document it's going to list here the actual IP addresses, ports, and protocols used for connecting your phones, Webex Calling app, gateways. Okay. Okay, so running into issues with firewalls and proxies with the security team, that's something definitely you may run into. So this is a document you definitely want to be aware of. This help.webex.com, port reference information for Cisco Webex Calling. Okay, so it talks about Webex Calling traffic through firewalls, manual proxy configuration, and it gives us a couple different proxy examples here. So we'll kind of continue down this document here. Okay, it kind of gives us a high-level typology as far as the different ports and the different services it leverages for Webex Calling. Okay, and then it actually defines the specific destination IP subnets on internet that it's going to be leveraging for the Webex Calling service, which is very nice. So if your security policy requires you to preemptively define what the actual destination networks need to be. This is something you definitely want to leverage. Please be aware this document does get updated from time to time, so you definitely want to go back and at the time of viewing this video, take a look at this document to see what the current information is. Okay, so it talks about the call signaling, uses SIP-TLS, which is encrypted, source ports from 8,000 up to 65,535, it's TCP based, devices using ports 5060 up to 5080. Okay, destination port 8934. Okay, it says here these IPs/ports are needed for outbound SIP-TLS call signaling from local gateways, devices, application source to the Webex Calling cloud destination. Okay. Okay, it talks about stun and secure RTP. Anyways, not to make this video too long, I'll leave a link in the description below on this video so you guys can actually go and take a look at this document yourselves. But very useful information. Definitely if your environment has very specific security requirements, this is something you definitely want the security team to take a look at, so they can make any changes that need to be made as far as the firewall rules, etc., etc. It also has document revision. As I mentioned earlier, these documents do get updated from time to time. So this is something that whoever manages the security policy/configuration deployment may want to analyze this from time to time to make sure there's no surprises. And so let's go back to the CScan tool and let's do a test another server. So right now I'm located in the United States. Let's do an extreme example, Australia. So that's actually a good distance away from United States or North America, if you will. So let's go ahead and do a quick test with this. Let's go and start. We'll go ahead and continue. Okay, right off the bat, you notice the latency is substantially higher. So it's still usable, but as I mentioned, you may be kind of working with almost like a CB radio, where you want to let the other party know that, letting them, stating over, and then the other party can go ahead and continue, speaking, and then they'll state over on their end, letting you know you can speak. It's not at that extreme point with 220 milliseconds, but there may be some points in a conversation where the two parties may step on each other because of the latency. Okay, so download is 26 megabits per second. Obviously, performance in that has taken a hit compared to North America. And then our upload's about the same, maybe a little bit higher, looks like. So let's see what it gives us here. Okay, so it gave us a yellow for the actual latency, which again is not too surprising because now we're in the, well, let me click that again, we're in the 200 to 300 millisecond for the round trip time, latency, if you will. So again, it's fair, it's not the greatest. Capacity were 7 calls again, the ports. In any case, hopefully this video has given you insight on what information is very critical to capture. Preemptively, even before you contact the Cisco partner and or Cisco tech support, if you're seeing issues and you're part of the IT department and you manage a telephony, it would be definitely smart preemptively to gather this information that we've covered in this video and have it all prepared, so when you contact the Cisco partner and or Cisco technical support regarding your telephony 3PCC issues, they'll be able to right off the bat have a lot of information at hand to analyze to figure out what is the next step or what is the next item that needs to be completed from a diagnostic and solution standpoint. Thank you for watching the video, and hopefully this helps you with your troubleshooting efforts. Thank you.